Okay, just a couple of examples. So using the formulae for the sum as well. So this is it. This is all you have to know for arithmetic sequences. It's in the formula book. Formula for the nth term, formula for the sum of the first n terms. You need to be able to prove that as well. And yeah, you need to check whether that one's in the book or not, but that's useful sometimes. So Ben starts a job with annual salary 15,000 and is promised an increase of £840 per year. How much does he earn in his 6th year? So all you need to do is decide, do you need the formula for a term or for a sum? So obviously this one, we just want the 6th term of the sequence. It's quite useful to write down what you know. So the first term is going to be 15,000. And also just think about what sort of sequence it is. It's going up by 840 a year. So it's an arithmetic sequence. Common difference D will be 840. And for this one, N is equal to 6. We want the 6th term. So the 6th term is equal to A plus N minus 1, which will give you 5. Times D. Just make sure you don't make a big mess over here. Just chuck it into your calculator and you get 19,200. What will his total earnings be after 9 years? So in this case we need the formula for the sum. A and D are the same, but in this case N is equal to 9 and we want the sum of the first 9 terms. So that's going to equal half times 9 lots of 2A, which is 30,000, plus N minus 1, which is 8 times by D. And I would be tempted just to put that straight into a calculator in all honesty, and looks a little bit healthier. Get 165,240. And then to find his total earnings after 6 years, because here we know the last term is 19,200, the sum of the first 6 terms, you could use this one here if you thought about it, or you could find the 6th, no, you wouldn't want to do that, or you could use this one. Yeah. But if you've got the 6th term, the point being is that you can use it, so you can do a half times 6, lots of the first term plus the last term, and that gives you 102,600. So that's just quite a straightforward example really, and I think this is useful. So let's do one more. So another arithmetic sequence, and we want to know how many terms if the sum of the sequence is 1,200. So similarly, you have to ascertain it as an arithmetic sequence. So it's plus 6, plus 6, plus 6. So that's all happy. A is 3. Common difference is 6. The sum of the first n terms is 1,200. And we're looking for n. So just plugging into the formula for the sum. So 1,200 is equal to a half n, lots of 2a, which is 6, plus n minus 1d, which is also 6. Too many 6's in this example. And then it's just working out through. I would times by 2 both sides first, just to get rid of this half, to be honest. So that's 2,400 is equal to n, and then we could also sort out this bracket. So I've got 6 plus 6n minus 6. the numbers won't always cancel out on there, but essentially you end up with a quadratic. So I've got 6n squared equals 2,400. N squared is 400, and then you could square root both sides on this one. So n is plus or minus 20, but we know that n is a positive integer because it's the number of terms, and so n is equal to 20 because n must be greater than or equal to 1.